It's Gurneet again and welcome to my channel. In the previous video, I showed you how to write your very first program, the Hello World program. We briefly discussed functions and data types. In this video, we'll be delving deeper into data types. Data types are structures that define how the computer will store data provided to it and how the programmer may use it. As a programmer, you may want to store various kinds of data types for different purposes. You may want to store the age of a person as a natural number if you're writing a program to store data about individuals, say, working at some company. You may also want to store their name as something called a string, which is basically a collection of characters, but I'll explain that in just a bit. You get the idea though. For different purposes, you need different data types. Before I start talking about the various data types, I'd like to explain what a variable is. A variable in any programming language is a memory space that is used to store data, and its value can be changed at any time later on. In some other languages, like Swift and C Sharp, you've got something called a constant as well, which is basically a memory space like a variable, but once you've assigned a value to it, you can't change it. On the screen, you can see some of the most common data types that we'll be using in Python. Let's start with integers, also commonly known as int. This data type is used to represent positive and negative numbers as well as zero. This means that it's any real number without a decimal point. For numbers with decimal points, we've got something called a float. A float represents everything that an integer does plus all the decimal numbers. You can't assign a decimal number to an integer. So why would you ever use an integer as opposed to a float, which obviously seems to be the better choice, right? Since you can represent a larger range of values with it. Well, sometimes you need to store only whole number data. The Python compiler will raise an error for you if you ever accidentally try storing a decimal in an int, which is actually a helpful thing. Also, arithmetic on integers is faster and they never suffer from precision loss, which is related to the way the data is stored in binary in the computer's memory. I might do a video later on binary maybe and explain that to you. Then there's the lesser known data type called complex number. To explain this, first let me tell you what an imaginary number is. An imaginary number is one that is expressed in terms of the square root of a negative number, usually the square root of -1 represented by j. The square root of a negative number doesn't have a real answer, by the way. That's why it's called an imaginary number. So complex in Python is a set of all such imaginary numbers and all real numbers. In the example that I've written here, j represents the square root of -1. Before we start with characters and strings, you need to understand what the ASCII table is. It's basically a table that encodes the characters we use on our keyboards as numbers. So each number represents a character that we can use. Character is basically anything on your keyboard like uppercase Q, uppercase A, lowercase u, round bracket, percentage sign, anything. And all of them have a number associated with them. A string is a collection of all such characters. And it's a composite data type, meaning that it's composed of another data type, which is a character in this case. So you get the point, like the string Python is made up of individual characters P, Y, T, H, O, N. So it's essentially a collection of characters. That's what it is. There's also another important data type called Boolean. A Boolean value can only be true or false. It's very simple. It tells you if a given statement that you've written is true or false. Like you write something like 3 equal to 4. Is that true? No, it's not. So Python's going to say false. You write the string Python equals Python. It is. So it's going to say true. So yeah, stuff like that. Lastly, I'll show you how to declare variables of each of the data types that we've talked about here. For that, let me open up my idle IDE for Python. So how would I declare an integer called x and assign it the value, let's say 3? I would do x equals 3, where x is your integer name, the variable name, and 3 is the value you're assigning to it. So now, in the previous video, I showed you the print statement. So print x Okay, yeah, just as a follow-up on the previous video, if you're printing a variable, you don't use the double quotation mark as we did back then. When you print any variable, you just don't use it. Otherwise, the compiler doesn't know that you're printing a variable. So if I do print x, lowercase, right? It would just print the letter x. Now, that's not what we wanted here. But yeah, okay. What if I wanted to print x equals 3? So I would do print x equals, and then comma x, and that gives me x equals 3. Alright, and let's create another variable called y and assign it the value 7. If I wanted to add the two, I would simply do x plus y, and I get 10, which is right. 7 plus 3 is 10. And if I did y minus x, I get 4. X minus y minus 4, both correct. And multiplication in most programming languages is with the asterisk sign. So x star y, 21, that's right. And division is with the slash sign. So y slash x, and that's a decimal number, right? So what if I wanted to get the remainder? You get upon dividing y by x. So I do y mod x. Mod is the percentage sign basically, and what this does is it gives you the remainder you get upon dividing y by x, right? So when you do this, 7 divided by 3 gives a quotient of 2 and a remainder of 1. Now what if I wanted that quotient instead? I do y double slash x, right? That works. Just notice that this is a float because it's got a decimal point in it. And how would I raise x to the power of, say, 2? Normally, I mean, the first thought I would have is to multiply x by itself, right? So x star x, I get 9. 3 squared is 9. So that's right. But when you have to raise something to a larger power, like say 7 or 8, it can get a bit tedious writing down x star x star x star, right? So Python's got this thing called POW, which stands for power. So x comma 7. This means that raise x to the power of 7 and give me the answer. So now when I press enter, I get 2187. How do I know this is right? Well, let's try this the tedious way, shall we? X star. So at 7, 1 more. And that's right, 2187. So that works. How would I now declare a float? Well, much the same way as an int. I'd just say f equals 1.02. That's it. Can it be negative? Well, let's give it a try. F equals minus 9.06. Yeah, f, yeah, that works. Complex numbers are easy too. So 3 plus 2j, c, 3 plus 2j. Yes, that works. Now let's try this. C plus x. You don't need to know the maths behind this really, but yeah, that's right. Just keep this in mind. In Python, you don't get an error when you try creating a variable with the same name as a keyword in Python. So something like print or input. So I could do something like print equals 3, and I don't get an error. That's not a good thing. I don't know why Python does this, but most languages do give you an error. But this is just not a good practice. Don't do this. So your variable name should be anything but a keyword. A keyword is anything that's Python specific. So if you want an easier way of remembering it, anything that changes its color in Python, so like this becomes purple, right? So nothing that becomes purple. So how would I now create a character? I'd simply say ch equals h, and I get that. Yeah. a string is quite simple too. S equals, let's say, Python for beginners. Yeah, that works. By the way, strings can be created with a single quote mark like this, or with a double quote mark like this, or when you wanted to go down to multiple lines, like S equals, like I could do this. A multi-line string would need a triple quotation mark, and that's how it would be. Now if I print this, \n means go to the next line. So over here it's just printing a \n, but yeah, it means that it's on the next line, right? Now Boolean. Boolean can only be true or false. So let's give this a try. B equals true. This is how you would create a Boolean, the most basic way of creating it. Or B equals false. Let's create another one called C equals true. Now let's see if they equal. To compare to Boolean values, or any values for that matter, you do is you use the double equal to sign. Single equal sign means assign the value on the right hand side to the left hand side variable. Double equal to means compare them and return true or false, right? So now B double equal to C, it should return false because true is not equal to false. Now that's right. Let's try comparing X and Y. You get false because 7 is not equal to 3. If I created another one called G and said G equals 3, you can map out that's got to be a single one. G equals 3, X double equal to G, that should be true, and it is. Now you can also compare them, like X greater than Y, false, 3 is not greater than Y. Let's just have this here. Y greater than X. What about X greater than 3? No, I mean G. Both have the same value 3, so this should be false, right? That's false. To cover the value 3 as well, you do X greater than equal to G. And likewise as the less than and less than equal to sign. Yeah, so that's it for this video. In the next one I'll be talking about string functions. Thanks for watching, and stay tuned in by subscribing to this channel. Thanks again. Goodbye.